Hello everyone and welcome to today's class. Today we'll be looking at chemistry past questions on the topic chemical equilibrium. For the first question we have here, it says, at equilibrium, which of the following statements is true for a reversible reaction? Option A says the forward reaction stops. Option B says the concentration of the reactants and products are equal. Option C, the rate of the forward reaction equals the rate of the reverse reaction. And D says all reactants are converted to products. So now, the correct answer here is option C, which is the rate of the forward reaction equals the rate of the reverse reaction. Now let's explain. At chemical equilibrium, both the forward and the reverse reactions continue to occur, but at equal rates. So there is no net change in the concentration of the reactants and products. This is why equilibrium is often referred to as dynamic state. Option A and D are incorrect because the reaction continues and not all reactants are necessarily converted into products. Option B is also incorrect because the concentration of reactants and products do not have to be equal. They simply remain constant at equilibrium. So our correct answer is option C, which is the rate of the forward reaction equals the rate of the reverse reaction. For the second question, which of the following changes will shift the position of equilibrium for reaction below the right? We are given the equation. Nitrogen gas plus 3 mole of hydrogen gas giving us 2 mole of ammonia. So option A says increasing temperature, option B says increasing pressure, option C says decreasing pressure, and option D says adding a catalyst. So the correct answer here is increasing pressure. Let's look further into this. According to Le Chatelier's principle, increasing the pressure favors the side of the reaction with fewer gas molecules. In this reaction, the left-hand side has 4 mole of gas, that is 1 mole of nitrogen gas and 3 mole of hydrogen gas, while the right-hand side has only 2 mole of ammonia gas. Therefore, increasing pressure shifts the equilibrium to the right, thereby favoring the production of ammonia. So, for option A, it is incorrect because increasing the temperature would shift the equilibrium to the left in this exothermic reaction. And for option C, it is also incorrect because of the same reason. And then option D does not shift the equilibrium position but only speed up the rate at which the equilibrium is achieved. Now let's look at another question, question 3. The addition of a catalyst to a system at equilibrium will A, shift the equilibrium to the right, B, shift the equilibrium to the left, C, increase the rate of the forward reaction only, and D, increase the rate of both the forward and the reverse reaction equally. The correct answer here is option D, which is increase the rate of both the forward and the reverse reaction equally. So now, a catalyst speed up both the forward and the reverse reaction by providing an alternative pathway with a lower activation energy. However, it does not affect the position of the equilibrium or the concentration of the reactants and products at equilibrium. It only helps the system reach equilibrium more quickly. Therefore, option A and option B are incorrect because the position of equilibrium remains unchanged. And our correct answer remains option D, which is increase the rate of both forward and reverse reaction equally. Another question from question 4. The equilibrium constant Kc for the reaction below is expressed as PCl5 giving us PCl3 plus Cl2. Now, we are asked to find the correct rate constant. And option A says Kc equals to PCl5 over PCl3 Cl2. Option B says Kc equals to PCl3 over Cl2 PCl5. And option C says Kc equals to PCl3 over PCl5 Cl2. And option D says Kc equals to PCl5 over PCl3 Cl2. The correct answer here is option B. This is because the equilibrium constant expression for a reaction is based on the concentration of the product divided by the concentration of the reactants, with each raised to the power of their coefficients in the balanced equation. Here, PCl3 and Cl2 are the products, and PCl5 is the reactant. So, the rate constant therefore is given as Kc equals to PCl3 Cl2 all divided by PCl5. So this is where we are going to stop for today's class. In our next class, we continue from where we stop.